Hey guys, what's up? Today we're looking at finding the line integral of a vector field. So we want to evaluate the line integral over the curve C f dot dr, where the field f here in this example is going to be sine x in the x component, cosine y in the j or the y component, and then x times z in the k component. And C, the curve C, is parameterized by r of t, which is t cubed I hat minus t squared j hat t k hat, and t ranges from 0 to 1. And the first thing we want to do is remember what is the formula for a line integral of a vector field. So the formula that we use to calculate most of the time a line integral for a vector field is integral from a to b, so those are just the bounds for t, f of r of t dotted with r prime of t. So we're going to need the vector field evaluated at the parameterization. So we take the parameterization, this first component is x, second component is y, third component is z. Take those three, plug them into our vector field, then take the derivative of r to get r prime of t, and then take the dot product. So the pieces we need are f of r of t, so this is sine of t cubed because I take x equals t cubed and plug it into sine, so I get sine of t cubed. I take y equals negative t squared, plug it into cosine, get cosine of negative t squared, and then take x, which is t cubed, and z, which is t, and put them in the k hat component, so t cubed times t. Also, I need to take the derivative. I need r prime of t, which is going to be 3t squared, negative 2t, and then 1. Now, I need to take the dot product of these two. So the dot product means just multiply the x components plus the y components multiplied plus the z components multiplied. So that's going to give me 3t squared sine t cubed minus 2t cosine negative t squared plus t to the 4. All right, so now I've got the pieces. I can stick it into the integral and evaluate. So this integral is going to become integral from 0 to 1, 3t squared sine t cubed, and minus 2t cosine of negative t squared plus t to the 4 dt. Now, I'm going to split this up into 3 separate integrals because each one is going to be a little bit different. So the first one is going to do a u substitution for t cubed. The second one is going to do a u substitution for negative t squared. And the third one, we're just going to integrate directly. All right, so the first integral, the u is t cubed, and the derivative is 3t squared. The second one, we're going to use a different subscript. It's going to be u2, and then that's going to be negative t squared, and du2 is going to be negative 2t dt. So if we substitute everything in terms of u, the bounds change. 0 goes to 0. When I plug in t equals 0 here, I get u1 equals 0. When I plug in t equals 1, I get u1 equals 1. And then sine of u1 du1 plus integral from 0 to negative 1, because when I plug in 0 for t, I get 0, but when I plug in 1 for t, I get negative 1. And then this is going to become cosine of u2, and then du2. So here's du2. And then integrate t to the 4, we just get t to the 5th, and we plug in from 0 to 1. All right, so now when we integrate sine of u1 du1 from 0 to 1, and we get negative cosine of u1 from 0 to 1. Integrate cosine of u2, we get sine of u2 from 0 to negative 1. And then when we plug in t equals 1, we get 1 over 5, and when we plug in t equals 0, we get 0. So it's 1/5 minus 0. And now we plug in the bounds, and we get negative cosine of 1 minus will be plus cosine of 0. Plus sine of negative 1, minus sine of 0, plus 1/5. Cosine of 0, that's 1, and sine of 0, that's 0. So plug those in, we get negative cosine of 1 plus 1, minus sine of 1, minus 0 plus 1/5. And lastly, we combine 1 and 1/5 to get 6/5. So we get negative cosine of 1 minus sine of 1 plus 6/5, and that's our answer.